Children, see, this is going to be another important corner where we can expect in the final examination. That's going to be Entgegen and Zusammen is concerned. This is like what's called here Entgegen. Zusammen means together, like cis, and Entgegen means opposite, like trans. That's going to be also considered as geometrical isomers, children. So this is absolutely based on CIP rules. That's called Can-Ingold-Prelog rules. Can-Ingold-Prelog rules, children. It's based on atomic number. For example, F9 is less than, chlorine is less than, bromine is less than iodine. It's based on absolutely on their atomic numbers, children. So that's going to be what's called here the first CIP rule is concerned. If the first atom is going to be, for instance, if the first atom atomic number is going to be different, like let us take what's called here CH3. Let's take what's called here NH2, because its first atom atomic number is 6, but first atom atomic number is 7. And if you have taken OH, its atomic number is 8. This is increasing order of what's called here as a Z value. Atomic number increases. So the priority also going to be increases. In this case, let's go to this, children. For instance, if the same methyl group you are given like this, it's lesser than 2 carbons. It's going to be same carbon atoms. If it is going to be 3 isopropyl, see here, this as the number of groups are going to be increases, priority also going to be increases, children. Lowest priority, next priority, next priority, and at last you can go for tertiary butyl also. So this has highest priority. The first priority goes to this based on size of the bulkiness of the group. And coming to this, children, fourth one, in case of isotopes, we will go through that isotopes. H11 is less than, D12, D1 is going to be less than, deuterium is less than that of T13. It's absolutely based on mass when the atomic number is going to be same. In certain cases, for example, you are given like cyanide, children. When you are given cyanide and you are given what's called here carboxylic acid, when you are given carboxylic acid here, children, then the highest priority goes to COOH than that of CN. Why? Because here the second atom is nitrogen, here the second atom is going to be oxygen. When there is triple bond like this, when there is a triple bond like this, you have to take, in the cyanide we are going to have triple bond, CN, 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 like the 3 nitrogen atoms we should consider. Here is the double bond, hence we should consider it's going to be C double bond OH, hence it is going to be COO like this. So then we should go for the sum of the atomic numbers or order of priority based on atomic numbers. It's one of the very, very precious relation which you have to learn this, children. Just I show you some examples, children, under the heading of this one. What is that we are going to see? I'll take this example, the double bonded carbon with what's called here fluorine. I have taken chlorine, I have taken bromine, and this is going to be iodine. Let us consider this first carbon and this is going to be the second carbon. As you are going to see this, children, the highest priority goes to iodine, first priority, and this goes to second priority on C1 carbon. That's going to be C1 carbon of the double bonded system. And this also, here its atomic number is more. This first priority goes to this, second priority goes to this. See Baba here, the groups which are having highest priority on the same side of the double bonded plane. That's why the lowest priority are going to be other side of the plane, hence it is called Zusammen. For instance, children, we are going to just interchange this bromine and this is going to be chlorine. First priority comes to this, second priority comes to this. First priority comes to this, second priority comes to this. On the first carbon, the highest priority one group is going to be below the plane, and the lowest one is going to be upper of the plane, double bonded plane. Here also, Baba, the highest priority group, upper side of the double bonded plane. These two are going to be opposite in the double bonded carbon atoms plane. That's why this is considered as Entgegen and Zusammen, Baba, here. Now, we will go another example also, children. This is EX number 1. We are doing with cyanide, COOH, and also I am doing CH3, and also I am doing here CH2CH3. Tell me, Baba, on the first carbon, which is going to be highest prior? 1. This is going to be 2. Whereas, let's do this, children. Just I'll go for a little change. I'll take here aldehyde group. Hence, the first priority comes to this. The second priority comes to this. Why? Because the double bonded oxygen is there in aldehydic functional group. Now, in between these two double bonded carbons, the highest prior groups are same side of the double bonded plane, that are going to be on the opposite side. Hence, it is going to be, what is say, children, Zusammen, like cis, like going to be together. They are going to be together, Baba, here. So, like this, we can do whatever we are going to do with respect to this Entgegen and Zusammen configuration is concerned, children. For instance, Baba, here, I'll go for CHO, I'll go for COOH, I'll go for cyanide, I'll go for isocyanide. The highest prior one is this, based on atomic numbers attached with the similar first carbon of this group. Second priority on C1. Come to here, the first carbon is carbon, first one is carbon, second one is nitrogen. But here this is going to be nitrogen having highest atomic number goes to this. Again, this is also Zusammen, yeah. So, like this, it's one of the possible question. So, after this, Baba, here, you have to, we are also going for another simplest case also. I'll take few examples of them based on what's called here same CIP rules, like whatever is called here rectus and sinistris configuration or and S configuration is concerned, Baba, here, based on what is called here dash and wedge, based on Fischer projection formula. See, Baba, I have given like this, and also this is dash and wedge formula I am going to give you, and this also what I am giving. So, whenever you have seen these two cases, it's called whatever is known as here. Now, whenever you are given this fluorine I am taking here, and I am taking here iodine, bromine and chlorine. And this here also I am taking fluorine. That's whatever is called here I am taking here iodine, let's go in this way, iodine, bromine and chlorine I am taking here. So, you are asked to answer this, whatever is called here, which one is rectus and which one is what's called here this, which one is rectus and which one is sinistris is the possible question. So that children, when you are going to given this question, wherein most possible, R stands for rectus, S stands for sinistris, that's R is going to be related with rectus in the sense, Baba, here, it's clockwise direction, that's going to be what you know as here clockwise, and what's called here sinistris is concerned anti-clockwise direction, Baba, here. So, don't use dextro and levo here. See, children, I'll tell you little simplest concept here. That's what we are going to do. We will do this in two ways. What is that two ways means? Here, highest prior one, iodine. Second one is this. Third one is this. Least prior group on dash. Dash means which is away from the two-dimensional board, and wedge means which is towards, which is projected towards us. When the least prior group on the dash, least prior group on the dash, See here children, this is 1, this is 2, this is 3. Okay, leave it all the things, just take that LPG is nothing but least prior group. LPG means least prior group. Don't think that it is liquefied petroleum gas here. Now children, let's go this. See how they are moving. The priority of the groups moving in clockwise direction. Forget about the least prior group, and they are moving in clockwise direction. Am I correct or not? Absolutely, Baba. Then this is named as what you say here, or. Of course, when we are going through this, the least prior group here also on the dash, but wedge is going to be here. That's going to have this highest prior one, second prior one, third prior one children. Now, let it be. When the least prior group on the here dash, then you write down the configuration as it is. You should write the configuration as it is. Now, let's go through this. It's going in anti-clockwise direction, right? So that it's named as sinistrous. Once again I am repeating children, don't worry. The direction whatever it might be, but that's going to be if the least prior group on the dash, then whatever you are going to do, you should write the configuration as it is. When they are going in clockwise direction, the priority of the groups are going in clockwise direction, it's mentioned as whatever is called here rectus. Followed. And whenever you are doing with this, when the groups are going in anti-clockwise direction, that's going to be sinistrous. That's going to be sinistrous here, Baba, here. And this is the simplest possible question for the level of NEET and mains. And children, I'll go for it. It's based on, we will answer this on Fischer projection formula. On Fischer projection formula. We will write down its Fischer projection formula. Then we will, once again, we will verify that. See, which is on the two-dimensional board, make on what do you say, vertical line. This is at bromine, this is going to be iodine. And next, whenever this is going to be on vertical line, for this, it's going to be left side, this is going to be right side. Write down, fluorine on right side and also chlorine on left side. Okay, Baba? Now, nothing is to change here. Let's give the priority of the groups. It's a chiral center. 1, 2, 3, 1, 2, whatever is called here, 3. This is the order of priority. See, when we have written, the LPG comes on horizontal line. What is that? The least prior group comes on horizontal line. What I have done, children? I have taken this only. I have written the Fischer projection formula for this. When these are going to be on two-dimensional line, that will be written on vertical in Fischer projection formula. And after that, if the, which you have written on the vertical line, if the dash 1 on right hand side, you should write on right only. But chlorine wedge is going to be written on left. Now, let's take this also, children. Whatever that, the two groups are going to be, what is that like? I'll write down. Chlorine here and on the two-dimensional plane, that's going to be on the plane of the board. And then, what we are doing, I am writing as it is. Here it is left. And this is also shown as left. It is also shown as left. So then I'll write them as it is. What is this? It's our best friend. It's going to be a least prior group. That's what we are going to do. And highest prior group is this. Third prior group is this, which is on wedge. I am writing like this, children. So left side, and I have written left side only. Keep it as it is. What's the wrong in this? I have given priority of the groups on the chiral center on the chiral carbon. Let's go through this, children. How do you answer whether it is rectus or sinistrus in terms of Fischer projection formula? right? Just look at this. 1. Second priority is bromine. Third priority is going to be chlorine. I am going in anti-clockwise direction. Forget about the least prior group. But what you will write, children? If you are going in anti-clockwise direction, you are going to write yes. Is it not? But it's ridiculously wrong. When the least prior group on horizontal line, S is nothing but R. S is nothing but R. See, here you got the R, here also you got the R. Once again I am telling you, children, this is, which is on the two-dimensional plane, bromine and iodine is written on vertical line. To this left hand side, the least prior group on dash is going to be right hand side. I have written on right hand side. And this is left hand side, the chlorine is on wedge. Okay, let it be Baba here. This is the case, the rest you can understand. When you have seen this, no, this is going in anti-clockwise direction. That's going to be what you say here. Our concept is related with this sinistrous. But when the least prior group on horizontal line, we should write in opposite way. Sinistrous represents R, so that its configuration is going to be R. Now, let's take this. Here also LPG on horizontal line. Highest prior groups as it is. That's what we are going to do in this way. Now, what I am doing, very, very interesting basics here. Now, let us see. 1, 2, 3, 4, right? Now, tell me, children. 1, 2, 3 priority is concerned. Whatever you are doing, it is also going in what direction, children? What's the direction which we are going to see here? It's F is written, see, whatever is called here, it's anti-clockwise direction. As it no, what we are seeing is anti-clockwise direction. No, children, there is a small rectification. So, whenever it is going to be left side of this least prior group, we will write down this same way for this, and we will go for bromine in this direction. Now, it's going in this direction, Baba. What is this? Clockwise direction. So, when it is goes in clockwise direction, then it represents what? Yes. Then it's going to be represent what? Yes, yeah. But here in this case, what we have seen is going to be, just we have done a small error here. Like this, we should go for this. Let it be left side, and that is also left side. We should write on left side only. But in opposite direction, we have to write. Let the dash should be written on opposite direction. So, these are the two things which we have done based on Fischer projection formula. But children, now let me do some more things. But I will give you here two more things here. How do you write the R and S configuration for them? It's going to be CHO. This is going to be CH3OH. H. Will you write the R and S configuration for this? Which is going to be highest prior group? It's the chiral center, first prior. This is going to be what? Second prior. This is going to be third prior. LPG is on, what do you say here? What do you say? On horizontal line. LPG is going to be on horizontal line. So that according to the CIP rules, we are going in this anti-clockwise direction, ignoring H is concerned. Ignoring H is concerned. So why? Because it is a LPG. When it goes anti-clockwise direction, LPG is going to be on this way, children. Okay. So that's why what you will write, its configuration is going to be R. Its configuration is going to be R, children. See, I'll take what's called here. See, this is the very decent example which we are going to do with respect to this. And like this, we can solve some more questions also, children. It's I have given CHO and also CH3. And this is I have given H. And this is what I am going to give you on the dash, which I have given like this, OH, right? And also I have given like this, CHO and the wedge is going to be like this. It's going to be OH, let it be on OH, and this is going to be CH3. And what's called here? I have given as it is in this way. H is concerned. See, very simple, no? With the dash and wedge. What's that, children? The highest priority comes to this, second priority comes to this, third priority comes to this. Don't try to convert this one. When they are on the dash, the least prior group on the dash, what are you doing, children? The least prior group is going to be on the dash. So that this should be written on vertical line, CHO, CH3. And this is going to be, H is right side. And no need, children, why should we go that? Directly we can answer this. Tell me now, what is it goes in the anti-clockwise direction, is it not? So that anti-clockwise means yes, right? When the least prior group is on the dash. Okay. Then similarly, this goes in clockwise direction. This goes in clockwise direction. Then it is going to be, what is say, children? OR. Okay. So this is the way of writing OR and S configuration is concerned. This is the way to write OR and S configuration. So based on this and this which we have seen here, so that we are done OR and S configuration also based on what's called here CIP rules, children. It's based on what you say, CIP rules. And I'll give you one question, COOH, COOH, OH and OH, H. There are two chiral centers. Just you answer this one in the next session, children. Suppose it's related with tartaric acid. This is also related with tartaric acid. And H and what's called here OH. And here H and OH. They are going to be different. Now you are asked to write them. It's called, first structure is this, second structure is this, I have given for you. And COOH, you can write OR and S configurations for them. OH. So whatever is known as here, third one also, children, I have given. And at last I am going to give you fourth one also, that's also related with the tartaric acid only. So children, 1, 2, 3, 4. Followed. What is this, children? What you are understanding? You can write, because there are two chiral centers. Write down OR and S, that you can do it. But I will discuss with you enantiomers and diastereomers. Enantiomers as well as diastereomers. Okay. We will do in the next session. Okay, children? What's that?